Hey, welcome everyone. Hopefully sound, everything is good. Just if you want to be, yeah, okay, thanks. Yeah, I'm seeing some name and faces familiar. Welcome everyone, and also new ones. So let's start. I think people are joining yet, but yeah, just we can start because to save time. So can you see my screen? Yeah, is it okay? All good. So today we want to talk about building efficiency, but the target is airflow analysis for improving efficiency, sustainability, and definitely cost saving. Before starting, because we have a combination of different experts here, safety engineer, structure engineer, project manager, director. So don't expect I'm going in detail about safety or safety processes because it's not enough 1 hour. Just I'm trying to cover case studies to see how safety analysis is beneficial in building industry. So feel free to send your question or comments during I'm presenting in chat. Then I'm trying to address any question you have. In case of skipping or missing any question, we will have around 5 minutes, 10 minutes at last. So I will double check all question in chat and refer. If not, feel free to call me, send me email, reaching out on LinkedIn, whatever. Happy to discuss more about everything. So yeah, let's just start. So who are we is a simple question, but a lot behind that to answer you. Definitely, the business owner knows what I mean because building a good company or engineering group is a lot. So the Duratec started 2019, definitely involving all required certificate for Australian engineering. But because of COVID and some issue, we all passed. So in 2022, actually, we started to help our clients. Most of focus is using advanced knowledge and engineering tools to present and help them for performance solution for different categories: residential, commercial, industrial. For Australia, definitely complying with NCC and Australian Standard. Also, I have some clients from overseas. We follow international standards, same as ISO. So the target is definitely sustainability, safety, comfort, and cost saving. So just we can have a quick just review to our website. Safety, we will talk about it today. We have also, we provide section J and JVC modeling report, and also acoustic and some FEA, combined with wind loading and fire, thermal analysis, and a lot. You can just dig in, and we have some happy client review that's from Toshiba, Hindmarsh, Innowood, and a lot. So that how they are happy, and this is what we are doing, keeping high quality, but we are very fast to answer our client. Anyway, just back to our presentation. So I need to have time here. So some of you know who am I, but just quickly, I'm one of the nature lovers. So in design, I'm trying to bring nature, natural sustainability, definitely all the time, because it's help environment, also saving cost. Yeah, my name is Shahram, but English nickname Sean because of easy to communication. I'm founder and director of Duratec, but before that, I work for Lendlease. I think Jesse is here. Jesse was my manager as a senior engineer. Welcome, Jesse. And before that, Aerocall, a lovely company, natural ventilation. I learned a lot and also put effect as a senior CFD engineer in ventilation. Before that, back to overseas, before migrating to Australia, I worked for a university as assistant professor. Definitely, we need to publish a lot of papers, you know, and I had some book published English and Persian, and one of them in CFD. But before, in parallel with before and parallel with university, I work for a big company, Farab Group, as a lead mechanical engineer. My qualification, unfortunately, all of them is mechanical engineering. I didn't, switch, for example, master or PhD. So all mechanical engineering. For summary, more than 20 years in CFD and mechanical engineering. I remember first CFD code by Visual Fortran I wrote was around 2000, 2001. So from that time to now, huge difference in CFD application we will discuss. So yeah, now I'm focusing on Duratec. We are a small engineering company, very fast, and maybe high quality, depends on our client and depends back to their feedback. So just a quick review, what is CFD, computational fluid dynamics? This circle one is applied for any simulation. If you ignore CFD, you can put FEA, acoustic, everything. So when we are talking about simulation, we have using numerical analysis. We call here CFD software. It can be FEA software, acoustic, thermal, whatever, to solve or to consider a problem. Here is fluid flow, a lot of equations using computer hardware. So when we're talking about fluid flow problem, back to Navier-Stokes equations, I don't want to, go equation just naming. A lot of effort, 500 years ago from Newton started, and then maybe before, to Euler and then Navier-Stokes. A lot of energy equations also can involve. So what parameter we are looking is velocity, pressure, temperature, concentration, humidity, and depends on the multi-physic or multi-phase or complex. We can add a lot of parameters here. So this is the target of equations. This is physics already convert to mathematics. But before computer and before CFD, it was hard to solve this problem. A lot of simplifying we can find in 1950 or 1960. But after around 1970, when first CFD code started, the famous one Fluent, from just a university thesis, and then now is ANSYS Fluent. So we have a lot now in 2024. We have open sources, same as OpenFOAM, commercial a lot, and some specialized, same as Six Sigma for electronic and data center or something like that. Depends on the application, or we can reach out to one of these softwares. But general comment, this is general comment. You can definitely feel free to reach out after to discuss, because I worked with most of them in the last 20 years, so I'm familiar with most. I'm not saying all, but most. So open sources is not user friendly, definitely, because it's Linux or no one, take responsibility of accuracy, reliability, or after sales services, no sale yet. So mostly in universities, or if we want to do something in automated way, we can go and use open sources. Commercial definitely is expensive, but reliable because a team behind that, and from 2000 or back to 1972 till now, a lot different. And I can't say, doesn't matter which software, for building industry, most of them accurate. And some specialized, again, depends on the application. We have, I don't want to go in detail, lattice Boltzmann, Navier, so what the differences, just for now enough. The challenge about hardware back to, I remember 2020 years ago, it was big challenge, because imagine your laptop or my laptop to now is multi-core CPU, and at that time it was a server room, 16 or 32 Pentium, or after that computer. So now, thanks to technology, we can use our desktop computer or laptop as a simulation computer for every simulation. Here we talk about CFD. Definitely high performance capacity clusters or computers available if we want to go further. For example, when we want to simulate a city wind comfort, geometry is big, or very small time steps. So we need a lot of memory or a lot of process. We can reach out. Cloud computing is popular now for Amazon, Microsoft, Google, a lot. You can pay hourly or different price plan they have, and use them. No need to buy a powerful computer or laptop. All of them, most of them, they are using CPU, but we also have GPU based on graphic. When I was Lendlease, I work with that. Still is under developing, much quicker, but not reliable yet because it's under developed. But I'm pretty sure in next few years, no one will use CPU for simulation and all GPU. So we need to wait. We will have a lot development, maybe AI involved in simulation, especially CFD, so we can decrease cost, time a lot in future. I know that a lot of commercial CFD software, they are investing time and money in R&D about AI involving CFD. So this slide, I think, is the most important slide in this presentation, and it's very simple question, but definitely needs very accurate answer. How can be CFD beneficial? So we are starting from design. When we talk about design, design is coming from initial, maybe consultant engineer. Mostly we call deemed to satisfy is based on standard. And if I can illustrate it for you, imagine deemed to satisfy most of the time is a key, but you need to open all doors with one key. Is impossible. So you need to use individual key to open individual door. This is the reason sometimes it's not optimal design, definitely expensive solution, because consultant engineer, maybe no time or contract or whatever terms didn't allow to go in detail. They call 70% of detail design and 30% contractor or supplier, and the main is 30% most of the time. So how is the game or between contractor and consultant companies going? I'm not saying all the time, but most of the time is copy from other projects and just slightly because of time. So this is the reason we need to redesign before application, or at least evaluate the design. This can be done by analysis. Again, you can apply this for FEA, acoustic, everything, thermal, but we are talking about CFD. An outcome can be verify the detailed design, just deemed to satisfy, or propose or verify a performance solution that maybe is cheaper, higher efficiency, and sometimes deemed to satisfy. You can't apply. I remember for a kitchen design, they couldn't send the exhaust to the street because it was corner of shop, all enclosed. So performance solution was filtration and back to kitchen, and CFD helped them to prove that this solution works for them. So higher performance, definitely you can't use CFD reaching uh, more expensive solution, or less performance, or hurt environment. If someone pays me or pay you for CFD simulation, outcome need to be better than the initial design, not worse. So yeah, the result is saving money, definitely. I'm talking about capital and in-front money. Higher efficiency leads to maintenance, lower maintenance, long-term running cost, same as less electricity, less bill, and definitely less carbon dioxide generation or sustainability design. So this is the how one simulation works. We focus on CFD here. So another question is that anyone knows CFD, just CFD, can help you. Imagine the client comes to me and asks me about CFD analysis for heart or blood. Can I do it? Yes, definitely I can do it. But what will be the report? The report or outcome will be beneficial for them? No, because I don't know about body. Maybe I worked 20 years ago, but I forgot. So this is very important and key point here. Reach out to somebody has knowledge, experience, qualification about safety. Also, I'm not saying being expert in, for example, building, but knowledge, experience, and qualification in that physics too. When we're talking about ventilation, I need to be a good ventilation engineer and CFD engineer. Then I can help my clients. This is very important. And unfortunately, some clients, because of cheap price or whatever limitation they are reaching out just general CFD engineer. And the result, I recently reviewed a CFD report for one client just as a peer review, and what was far from whatever a client wanted, because no knowledge about that ventilation on physics. Just general safety engineer did good job about safety, but the result wasn't beneficial. Anyway, so let's move on. So we can talk about CFD application in building a lot, extend this list definitely, but let's just focus to category, indoor and outdoor. Definitely, indoor air quality is one of the most challenges here, and this is related to car park, kitchen, fire, and smoke. Healthcare, the hospitals or aged care, that safety is important over there. Second category is heat, cooling, and ventilation modeling, HVAC, thermal comfort, energy efficiency, mechanical, natural, and passive ventilation. Is very vast, very wide, and just general note, 30% to 50% of building energy bill is going for this category. So it's very important this category be optimized to save costs for clients, mostly long term for running. So outdoor, we definitely, when we talk about building, wind is a big challenge, so wind analysis. So we talk about wind loading, cladding pressure, and wind comfort. We will discuss about them in one slide, and rain and water, because always we have wind driving rain. So facade elements, facade same as lower windows, or roof. We have a lot of penetration and leakage issue. So we try to just have a case study about louver to see what's going on. So yeah, indoor, again, car park, kitchen, healthcare, fire, and smoke. If we start from health, or it can, again, it can be applied everywhere, outdoor. So we have some source of pollution. It can be everything. And we are able to, by safety, to show in detail, because it's 3D. If you wanted to do something like that in reality, is very expensive. You need to install sensor everywhere, even in laboratory. But safety, it has ability to show the 3D of what's happening, where is this dead zone, or how it's going. If we are designing ventilation, how it works. So another application can be kitchen. Kitchen is the main source of pollution in urbans. A lot of, I think, in Sydney, we have a lot, especially in CBD restaurant, commercial restaurant, and always you can smell other and oil, burn oil smell, and this is poison. So when we talk about kitchen, we talk about wood design, how filtration going, or this exhaust, how many percentage of this contaminant or whatever is it going to streets, and you need, if designer or whatever, you need to get council approval for that. So safety can help to prove that, okay, you are in the good position. Or even in restaurant, you can measure by CFT CO2 level or CO level or everything. So this kitchen, especially commercial kitchen industry in hotels, or some big, very huge brands, is very challengeable. So safety can help. Car park is another classification. It's pretty standard, because most of design is deemed to satisfy, and they are not optimal. So performance solution accepted by NCC, safety accepted by NCC, we can use performance solutions work or not. So we need to keep a CO level on the required ppm mentioned in NCC and AS 1668.2. Another category is fire simulation and smoke visibility. We are not talking about fire design, because this is belong to fire engineer. We're talking about simulation and visibility. Maybe fire engineer wants to see the ventilation design, or whatever design ventilation is okay for exhaust smoke or whatever. So safety is in a position to show 3D visual, 3D smoke visibility, and a lot of further. Also, we have some specialized safety software for a smoke and fire in markets. So it depends on the application we can use. So let's start with one case study for car park. This car park is a very big car park, 252 parking spots. I'm checking anyone wants to come. So it has mechanical system, 2 exhaust and supply fans, and also from ramp we have intake air. So we are looking to decrease jet fans from initial design, because initial design is 18, and we are looking to optimize the design. So 50 Newton jet fan was selected based on initial design, and then geometry build up. Geometry suitable for safety. We no need for safety a lot of details or mechanical details. Just simplify for mesh generation and also apply the jet fans. So, and the result for this particular project was decreasing 18 jet fans to 12. And 1 hour average CO is 45, less than 60 ppm required by the standard, and 1 hour maximum peak one, 85, less than 100. So this solution complies with NCC and achieve almost 30% cost reduction. I mean, in front cost, because definitely running costs also is decreased. And this is how safety can help and be beneficial for saving money, comply with NCC and standard, and definitely health and for example, car park is very important. We need to see 1.5 or 1.8 meter above the floor, and also 750 millimeter. For example, a child or a kid going with asthma is very important. So this design can kill someone, wrong design. So it is very important. So let's move on for next category. So I'm watching the time to save time for last questions. HVAC and ventilation is a huge area that CFD can be beneficial. So imagine here it is a factory, and look at temperatures, and workers, they are working here. 180 is the maximum, definitely is machine, but when here is 180, here it can be 100. So CFD can help to identify dead zone or hot zones to design a well ventilation method. So definitely air circulation can help us to see, okay, where we don't have, for example, air enough, so then we can change our design or add a fan or whatever is it. So this is in an apartment, and the split or duct HVAC, you can see that how it takes time. We can predict how many times it takes to room getting a temperature out, so we are able by CFD to see where is the dead zone. So we're talking about thermal comfort and energy efficiency, and also optimal design of equipment, because most of the kilowatt we are selecting is just numbers using from simple calculation or from standard. Again, they are not optimal, especially when we are dealing with big projects, same as hotel, hospital, or very big residential tower or office. So it's money. If we can decrease the kilowatt, it means it's saving huge money for client. So this is a spa, and this project they had, because it includes no access to the outside because of privacy, definitely. So the challenge was which air change per hour is suitable for this 24-hour or something like that, or even 12 hours. I don't remember. It's by using by different people. When one person patient or the book with other or group. So we designed a ventilation, natural and mechanical, one fan and one exhaust. And with this CFD, we show that, okay, this solution is work well, and we can rid of humidity very quick and effective. We can talk about some product development, same as this fan, how it works, or some lower design. So all can be fit in this category, and safety is beneficial for all of them. So definitely we can use some thermal imaging scan camera to see before and after what's happening in the factory or office or whatever. So it helps to verify our safety results too. So as a case study, yeah, that factory thermal comfort, we can have a look. So this special project it has a lot of machine, but here simplified, just a case study. We have heat source, so we need to manage this heat source. So we have initial design, ventilation design. First, safety can evaluate it work or not, and then change the design, optimal design. Maybe it takes 2 or 3 or 4 times safety simulation. This is good things about safety. We can change geometry, see what happened, and then come back, refine geometry. So it's very, I'm not saying easy, but it's possible. So the target is compliance with HVAC 55 standard thermal comfort. So it's not office because PPD and PMV level for human comfort apply for office or residential. Here, this blue area, but because it's factory, we are using natural ventilation, ridge vent, lower or fan. We're just decreasing the temperature, bring the temperature to as far as low. So for this particular project, we were the position 13 to 28 degree above the ambient, but we could brought less than 8 just with natural ventilation. So definitely operation cost reduction 10% because of running costs, no fan, and also when it's cool, machine work better, higher efficiency, and also people. You can't work in hot area, very comfortable. But when it's cool, or I'm not saying cool, but maybe it's just normal, your efficiency also going up as a labor. So also reduce carbon dioxide for this project because we use natural ventilation, so definitely no mechanical. So client was very happy. Maybe a bit in front cost because of natural ventilation is high, but no running costs. So it talks about saving money for the client. If you have any question, yeah, again, just feel free to send me by chat. Then I can refer when I'm, just presenting. Yeah, so this bird bring us to wind. Wind is very important. Just before just going to what happening, this popular video from Euronews, and we can see how wind between tall buildings is different from the cross junction. It's not because of we have gusting or wrong design or no one care about the higher building. Another thing very important downstate. So how wind comfort, especially is very important. We have some areas in the low comfort. Actually, the low. Stated, we want to go through it and see from the how we. So, fortunately, most of such things not priority to look at to look for wind comfort or wind safety level or this is wrong. So when we're talking about wind, we can talk about cladding pressure. You can see that is not just a fixed number, is oscillation. So it can be one side positive, one side negative. So definitely wind tunnel is popular, and wind tunnel test can give us the if you can, sorry, just put in chat for me is better, because for saving time, maybe if I allow to speak, maybe we can lose the time. So I appreciate if you can just text me by chat, then I can refer your answers. Okay, so I'm not saying that CFD can or wind tunnel test can replace by CFD, but I'm saying that even wind tunnel test is not accurate, because we are talking about model and very simplify. So in this case, in this scenario, CFD can simulate the prototype, the real building, and this is beneficial for us. So each of them has disadvantages and advantages, but definitely if you want to check your design for building or cladding pressure or ventilation, whatever, CFD is cheaper and quicker, and repetitive is easy to change design and evaluate. But in wind tunnel test, it takes ages to rebuild the model and then retest. So this is the reason CFD can help in building design, especially for wind loading. So just case study, I think, I'm not sure my client be involved in the design here, Said. So we did, okay, the problem for, this is a hospital. So the problem was that this is the cladding. We have one cladding here, then top hat, then some bracket, and then insulation, then one plate they call backpan, and then internal wall. So the problem was that the consultant engineer insisted to design or this backpan in pressure same as external cladding pressure. So it means they require to use 0.9 or even more thickness, this this sheet metal, instead of 0.7 that maybe they participated in tender and they won based on this. So huge money. Imagine big hospital and all facade is huge money difference between the thickness for them. So is this challenge was they reached out us and we involved, and we helped them with CFD. We calculated the pressure reduction in a gust wind, and you can see from here, definitely here is the outside and here is the cavity inside. We can see the pressure can decrease from 2 kPa to 1.4. So around 30% decrease, and this 30% or 35%, because we have one other factors, help them to be able to follow 0.7 millimeter design. And this kind of problem maybe is very niche and unique. You can say, oh, is same as car park is standard application, definitely. So this is the reason I need to educate my client. Okay, this is the capability of CFD in a structured design. Okay, because normally structural engineer, they no need CFD for their design. You can confirm we have a structural engineer here, and just using standard or data from just basic calculation. But again, CFD can help them first verify the design, and second, decrease the structure, the material thickness or material type, even sometimes opposite, help them to evaluate better. Maybe the structure is weak. So this is the position that CFD can assist structural engineers to succeed in their design. So another category we can cover is rain and water penetration modeling. When we are talking about rain, because you can't imagine building a building design without rain, because all building design, they are considering wind. But for example, for Sydney, 50% of days a year, even more, just I'm giving an idea, is we have rain. And sometimes we have, even we live in nearest to ocean or some high wind area, this is a wind driving wind. So we need to consider rain and water penetration, especially in facade element design. When we call facade element design, can be from lower, that is open, or window, doors, cladding, cavity. We had what else? Brick, and anything in facade can put in this category. So we have different standard apply. For example, for window, we have different infiltration or penetration standard. For is different for residential properties. With commercial, depends on building class. In Australia, we have classification. Definitely, every country has its own standard. So depends on the classification. All tests down in in laboratory. So it's a actual test, but we are in a position by safety to do virtual testing. So some of these tests is easier than others. For example, if we want to talk about penetration for this window, is very hard job because we need to consider all gaps very accurate to see in that pressure what happening for this rain. Some of them is easier because lower already open, so we don't need a lot of details on it. Another project I did for a good client from New Zealand, this is the cavity pattern, and they wanted to see its performance for drainage when rain coming in from roof, penetration going to cavity between cladding, for example, and wall. This pattern is for ventilation to decrease mold or condensation generation. So this has two applications. One is ventilation, cavity ventilation, passive ventilation, and another is drainage. So CFD can simulate what happened for example, if we have a column of water here, just a simple one, and how long or how this pattern they call VB10 drain the water properly or time, and we can discuss with this video, or also we can go farther based on applicable standard. So as a case study, here, for example, roof vents. Roof vent also is another category. I remember I was in Mercedes-Benz, I think Seven Hill was, and one of vent didn't work well for rain, and $500,000 car just, water dropped on it, and they weren't happy because very expensive car, just a lot of rain maybe damaged it. So sometimes this we think simple design, but maybe affect the wrong design affect a lot for client. So just let's consider this case study as rain resistant performance test, visual test for a LOVA. So this test is based on AS 4740. The standard says you need to test for heavy rain flow rate. 75 liter per hour square meter. Is very heavy rain. And also wind needs to be, or wind or airflow 0.5. If we consider 1 by 1 meter, it means 5 meter per second to 3.5, sorry, airflow. And I forgot put here the wind. Wind need to be 13 meter per second in middle, in 1 meter before the lower. So wind, again, wind need to be 13 meter per second. And also we have some airflow. So the target is testing and classify this lower. For example, this class A means 0.99 percent or whatever, 99% can be resist against rain. Is class A, then class B, class C, and class D. And less than class D, it means just you are living outside and rain is, in your office or place. So the result is we can measure the rain penetration in each velocity and then classify this lower or this product for any application. Most of supplier, I did a lot of this job, a lot for most of lower companies in Australia. They reached out to me and I did a lot for them: rain test, wind load test, airflow test, acoustic test. We did a lot for them. So this is a category maybe just back, we can say back to supplier. But sometimes contractor also in projects, you need to verify this lower, it is good to go or not, or this window or this door. So we can help with this simulation. So we have 10 minutes. So I promise give you 10 minutes if you have question. So first of all, thank you very much for attending. The video, I recorded it, so the recording will be available on our page in LinkedIn and also website. So feel free to come back and, or your friend, your colleague missed participate, understandable, because in Sydney is lunchtime, easy time for us, but maybe other cities or other country appreciate some of them is maybe night. We have some from Canada, US, Europe. So I appreciate to join us. This is the reason I didn't focus Australia, less mention Australian standard, but happy to help if you have inquiry or further discussion or questions. This is our general email. On my email is shown in staffdesign@duratec.com. Feel free to reach out. Phone number, Australian number also. And please follow us on LinkedIn. So if you have any question, I am available. I can, if you can, okay, just chat. Some of them you can't hear you. You can hear me or not? Is that you have my sound, Jesse? Yeah. Okay. Maybe it's, sorry if I think one of sorry if you couldn't hear. Anyway, the recording will be available very soon, so feel free to review the recording if you missed some. Maybe issue is Susan with your sound, your speaker. I'm waiting for some question. Yeah, no problem. Just, yeah, feel free to reach out and we can discuss more. Yeah, if we just go quickly to our website. We have some solution here. We talk about the solution here and which is beneficial. And also we have resource page. And resource page, likely white paper or something like that. So you can find your interesting topic. And also please give me feedback, because I'm trying to have a regular webinar, different topics. So it's good to know what topics is more hard, more interesting for you, so we can focus on topics. For example, JVC, I will have some webinar very soon, or another. For example, if you think wind loading needs to go a bit dig deeper, we can have a webinar just for wind loading or just for wind comfort, or other category, for example, category sound modeling or acoustic. So please help me. Yeah, just we have one question. In modeling, did you consider the temperature increase from outside the building? Yes, good question. Depends on the application. We can apply, if you mean solar or radiant or whatever, we can apply in safety. In safety, anything about environmental, humidity, temperature, pressure, we can apply. But end of the day, if we add these items, we are making our problem or our case complex, and complexity means time, and sometimes not worth it. You know, for example, some consultant engineer insists to have every detail in safety, but end of the day, the result is a slight difference. So this is the reason we need to find balance, which parameters is essential and necessary. This in CFD. This is the reason we need to evaluate or reconsider our design before starting CFD. I hope I answered your question. If not, just feel free to send me by email or LinkedIn or call me. We can discuss. Another, for safety cladding assessment, do you consider the transient simulation or steady state with peak factor correction? Both of them is possible. Again, for if we want just for peak, steady state enough, but some high-rise building, and when we have gas or wind, we have oscillation. So definitely we need transient simulation to see how pressure going down and up, because sometimes negative pressure is more dangerous than positive pressure. So again, back to design or case study, we can consider transient or steady state calculation. I hope enough, but again, if it's not enough, just feel free to reach out after this webinar to discuss more. Anyway, if not question, maybe we can wrap up, and thank you again for all for your support, your being here, and yeah, have a lovely day or night if you are in overseas, and hopefully see you again. Thank you very much.